We have some highway design plans, and we're told we have this scenario that we have a curve with a PI at station 32 plus 30.09. So that's this portion of the design plans. And we want to move that as close as possible to the preceding curve that has a PI at station 22 plus 28.74. We don't want to impact any of the curve components. That includes the radius, intersecting angles, cross slopes, lengths, etc. We just want to push these close together for some reason on this project that would be beneficial. And we need to find this station of the new PC for that curve that's existing that currently has a PI station at 32 plus 30.09, but that will change as we move that curve closer to the preceding curve. So taking a closer look now, I've kind of taken out some of the extra information to zoom in a little bit. A couple of the components that will be important, this 17-foot increment to change 1% in cross slope, and it's the same for both of these curves. And really the big thing we have to worry about when we're doing this is that we have curves in the opposite directions. So the super elevation is going to be pointing in the opposite directions. So in order to push these as close as possible, we can't actually put the PC and the PT together, the PT for one and the PC of the next, because we're still doing cross slope changes after the PT. So here's our PT station for the first curve. We're still having transitions for the cross slope. And then before we reach the PC, there's transitions to this point. So we've got to be careful on how close we can put those in. And essentially what we can do, the most close we can put them, the most common point, close common point, is where we reach normal crown. So we're going to have normal crown at these 2 points. That's what we'll try and do, is push those together, and we'll get that PC station as close as possible to the existing curve. So that's the 2 points that we're going to end up pushing together. And this is what the current scenario basically looks like. So here's our first curve with the PT at station 23 plus 90.39. Here's our second curve with a PC of 30 plus 55.52. And we see that we've got some cross slope changes that happen past that PT and cross slope changes that happen before the PC. But we've got this extra section of normal crown in here. So essentially what we want to do is just remove this section of normal crown. So this is what the relative gradient profile would look like if we remove that normal crown and kind of squish these curves together. And so what we're looking for is that station, the new station for the PC after we push these two together. The assumption that we have in here, we have simple curves, and we're assuming that we're distributing the super elevation runoff in 1/3, 2/3 increments as shown here on this diagram. So now in this image, we're showing these two curves pushed together. So there's as little a gap as I can do, just pushing, copy and pasting and clipping those images together. So what we're going to have to get the increment, we're trying to find this from this PT station, where is the new station of the PC? It's not going to be 30 plus 55.52. That's the old stationing. So we want to go from, again, our PT station, and these increments are going to be helpful. So we have 8 different increments of change of 1% in cross slope. Each of those were given as 17 feet. And then we have 2 smaller partial increments that are basically 2/3 of that increment from the PT and then to the PC there. So we're going to start at that existing PT station, 23 plus 90.39. Then we're going to add those 8 increments shown with the red arrows here. Each of those is 17 feet for a total length of 136 feet. Then we're going to add 2 more increments. These are the yellow arrows here. Those are 2/3 of 17 feet, so it ends up being 22.67 feet. And so now we're just going to add this up. 23 plus 90 plus 136 plus 22.67 feet gives us a new PC station of 25 plus 49.06.